Um, so in this video, I will explain a simple cryptographic project implementing four cipher options like shift cipher, multiplication cipher, polyalphabetic substitution cipher, also called Vigenère cipher, and finally simple columnar permutation transposition ciphering. So, so all of these cipher methods are encryption methods are symmetric, which means that the sender and receiver shares the same key, and the same key is also used for encryption as well as for decryption. Sorry. So in order to keep things consistent, my code encodes characters using printable ASCII codes from 32 to 126, and it works with indices 0 to 94 under 94 modulo 94 arithmetic. So let's go through the codes. So in the codes, I first define this helper function called toIndex and fromIndex. So it basically converts character to index, and the fromIndex converts the indices 0 to 94 back to the characters by adding 32 and using the CHR. Sorry. Um, so this allows all the ciphers to share the same alphabet and formula from C equals to FPK1 times mod 95. So let's go over to shift cipher now. The shift cipher is the kind of the simplest one among others. For each character, the plaintext index P is increased by a fixed key K modulo 95. Sorry. So we have the formula PC equals to P plus K modulo 95, and the decryption is the same thing but inverse, like P equals to C minus K modulo 95. So in this scope, I loop over each characters, convert to indices with toIndex using that helper function, and add or subtract the key, apply the modulo, and convert them back using the fromIndex helper function. Characters outside the printable range are left unchanged because they are not read by our helper functions. So this is how we do the shift encrypt and shift decrypt functions. Going over to multiplication cipher. The multiplication cipher uses this formula called C equals to K times P modulo 95, or modulo n is 95 in our case, so I am saying 95 instead of n. So then to decrypt, we must find the modular inverse of K, because since we're about to find the P, we have to divide C by K and do mod 9. So C divided by K is when C divided by K can be said as like when K comes up, it's like an inverse. So K inverse times C equals to P. K inverse times C mod n equals to P. So that will be our reverse decryption formula. So to decrypt, we must find the modular inverse of K modulo 95, a number K inverse such that K times K inverse equals to 1 and mod 95. So that will be our formula. So this only works if our greatest common divisor K95 is K should be within 95, and it should be 1 when divided by 95. So in my implementation, I choose keys like 7, 3, 7, 3 or 7, which are coprime with 95. I implement this inverse using the extended Euclidean algorithm in a function mod underscore inv, which is this one. So this uses the Euclidean algorithm, and the encryption and decryption loops are otherwise structured like the same as the cipher algorithm, like just in here. It's kind of similar but little bit different than the shift cipher. Okay, let's go over to Vigenère encryption, and let's see how it's been done. So this cipher technique is a kind of polyalphabetic substitution, So instead of a single numeric key, I use a key string. For example, I have done it like this key is actually a string, like as we can see in the example. This one. So I have used a key called secret key, which is used to encrypt and decrypt this the given text or the given message. So for encryption, what we do is C equals to P plus K mod 95 or mod n, and for decryption, which is we can find P, which is C minus K mod 95. So in this code, I pre-compute an array of key indices. So I compute the array of key indices, then loop through each message, like I have done in here, like for ch in plaintext. So I have looped over each message, and for each printable characters, I add or subtract the corresponding key index and move to the next key position. So in this case as well, non-printable characters are copied unchanged and do not advance the key indices. So this is the same thing but in a reverse way. Let's go over to the simple columnar permutation transposition now. So in other cipher methods, what is done is all the text are being changed to something garbage or something random text, but in columnar transposition, what happens is that only the positions of the characters are changed. So I choose an integer key that represents a number of columns, for example 5. For encryption, I have used 2 instead of 5 here, but you can use anything. Okay, so okay. Sorry. So where are we? So for encryption, in order to encrypt, what we have done here is we first compute how many rows are needed. Like I have done here, rows equals to math plus ceiling of length of the plain text by columns. So the number of columns, we define how long the decrypt and the changes will be. So it's better to keep it short and sweet for at least for this class. So we fill a matrix of rows by keys. So the dimension of the matrix will be rows x times keys. So it is done row by row with the plain text, padding with the spaces if necessary. So we read the matrix column by column from left to right and concatenate the characters to get the ciphertext. For decryption, I'm so sorry. For decryption, we just do the reverse of what we did in encryption. So what we do is create an empty matrix with the same number of rows and columns, then fill it column by column using the ciphertext. After that, we read the matrix row by row to recover the plain text, and then strip the trailing spaces that was used for the padding purpose. So this keeps the characters the same but permutes their order. So let's see the example of how we ran the above things. So the plain text I used is algorithm finals test 1 2 3 test. So what happened is I ran each cipher methods like shift cipher here, multiplicative cipher here, Vigenère here, and columnar transposition here. So while I ran, I found the output is like this. So what we have here is the the first example. This is the random text, garbage text that's been generated, and while decrypting, the same text is being generated again. It's the same with other things, other examples like garbage, and then the same text that was provided as an input is the same in others as well. So this is how the code is being run right now. So this is the explanation of each approach, the code structure, and there's a simple example for each of the cipher methods. Thank you.